Lian, how are you? Okay, it's 8 o'clock. We'll get started. Okay. This week we will be on the chapter 6. Okay, we will finish this course at the end of the month. Okay, so pretty much we still probably have 5 weeks, including this week. Okay. So this week we will be on chapter 6 on the functions. And in addition to that, in the data science side, we will talk about the Matplotlib. Okay, so this is a little bit different. The Excel data sheet already finished, so we will do the Matplotlib today. Okay, so actually will be on Matplotlib. Okay. First, we need to know what is Matplotlib. Okay, I will not cover too much of the function today. Primarily will be more on the data science side. First, we need to know about what is data science, and then we are going to talk about data visualization, and also the relationship of the Python with the data science. Okay. So first thing you need to know about the comparison of MATLAB and the PyLab ecosystem. This one, okay. This is a comparison of the MATLAB and the PyLab ecosystem. First, this figure, I would like to actually give it to you. So, comparison of MATLAB and Python. So this one is the comparison for the Python and MATLAB. So why we need to compare these two? That's because that in the old days, MATLAB is the first mathematical tool. Okay, for using the computer tool for mathematical tools. And then Python and PyLab become a new ecosystem that actually is supporting everything that MATLAB can do. Okay, so originally a lot of people using MATLAB, and later people jump into the Python, PyLab. Okay, so you need to learn core Python, that's actually needed, and then NumPy, Matplotlib, SciPy, PyQt4. Okay, PyQt4 is a Qt package using Python. Okay, and then this whole thing supporting the similar mathematical tools that in MATLAB, Simulink image processing toolkit. Okay, so these two actually are the major scientific computation tools. So we talk about this just because that we would like to let you know that scientific computation, Python is a very important language for it. Okay, so here we list down the advantage and disadvantage of the MATLAB comparing to Python. Okay, this one you can study. So now let's go back to the slides. So today we are going to talk about function, but in order to talk about function, we also would like to talk about data visualization, okay, in Python. So data visualization is that you've got a function, you try to show it. That is the data visualization. Okay, so we will talk about fundamentally what is a function, and then what function can be represented. And we will talk about Matplotlib, NumPy, and PyLab, and then how to make different charts and how to decorate the chart. Okay. So first is NumPy. NumPy is NUMPY is actually called numerical Python. Okay, so we installed NumPy for you already. Another one is called SymPy, symbolic Python. Okay, so there's a numerical Python, there's a symbolical Python. And then we have SciPy, scientific Python, okay. And then Matplotlib, PyLab, okay. So first, PyLab is a combination of Matplotlib and NumPy. So if you say from PyLab, import the star, you basically import NumPy and Matplotlib together. Okay, so NumPy is a mathematical tool for the Python, but it doesn't include in the plotting part. And the Matplotlib is the plotting part. So these two combined together, we call it PyLab. So PyLab is similar to MATLAB's function. So it primarily providing you the mathematical tools and also the graphing tools. We call it PyLab. Okay. And SciPy is actually 18 more mathematical classes and functions used for scientists. So SciPy a little bit like the scientific package that you have in MATLAB. So SciPy is a little bit like Simulink and image processing tool. It's more like this. And NumPy and the Matplotlib is a basic core processing and data representation for the mathematical tools. Okay. Okay, so far you probably still don't know about the example. So that's why we get started. Now, first thing is that you need to know about what is Matplotlib. So Matplotlib by its name is actually called matrix plotting library. Okay, so it's used to plot mathematical data. That's what it's called. It's a Matplotlib. Okay, so you actually can do plotting. Okay, we'll talk about this the detail of the Matplotlib later, but just right now, just know about it. What is Matplotlib? And Matplotlib can be using PyLab to include it, and PyLab is Matplotlib plus NumPy. Okay. So including the 2D and 3D tools, okay? So right here, we'll talk about how to import them, but later we will show you the example, okay? You have two different ways to import it, but it's okay. Right now, let's just stop right here, okay? But let's change gear to look at the differences. So in high school, you do learn about the pre-calculus. Okay. Sherry, let me ask you, what do you learn from the pre-calculus?
Like maybe like sines, cosines, like angles, the radians, the
Sine, cosine is called trigonometry. So
Yeah.
why this course is called pre-calculus? So in high school, you do have algebra 1, algebra 2, you do have geometry. You do have trigonometry. Okay, why there is a course called pre-calculus? So what do you really learn in pre-calculus? This question, if you cannot answer, let me ask Benjamin. Benjamin, what is a pre-calculus?
What is pre-calculus?
What really you learn from pre-calculus?
Like, okay, so I don't.
What do you learn from algebra 1?
That was before COVID. You're asking me a question. Oh,
Hmm?
that was 5 years ago.
It doesn't matter. If you really learn something, it doesn't matter how long you've learned before. I learned algebra maybe 40 years ago. It doesn't matter. You didn't get the key idea of what it is. So Brenda, how is algebra 1 or algebra 2 or pre-calculus? What do you know about this math? What do you learn from there?
Algebra 1 is like solving for basic variables.
Well, you have
And
heard
then-
about, yeah, that's correct. So what is algebra 2?
Algebra 2, it's like quadratics.
Quadratic, okay. So this one may be y equals 3x plus 2. This one may be y equals s squared plus 2x plus 4. And then what is the geometry?
It's like it has to do more with shapes, but it also involves like it needs algebra 1.
So you talk about maybe the two angles are the same if they are parallel, those kind of things. So you actually study the relationship of different shape and angle and the length, right?
Yeah.
Pretty much you analyze anything that represented in the geometry and then try to understand the mathematical relationship of those different shapes or angles, right? So what is trigonometry? So what do you learn from trigonometry? Have you learned this one or no?
I learned as part of algebra 2.
You are taking the pre-calculus next year, right?
Yeah.
Okay, so you don't need to answer this. How about Ian? What's this different mathematical term to you? Which part you already learned, which part you haven't learned?
Well, I learned algebra 1 geometry and algebra 2 and like the beginning of trigonometry.
So you are going to here and here next year, right?
Yeah.
Okay, the reason why I'm asking you, all of you, about this is just because today our topic is very much related to function. But you must know about what is a function. Okay, you must know about what is function. So in a way that actually pre-calculus, let's look at pre-calculus. Pre-calculus means any math that is not calculus, not involving calculus. So calculus is integral or and differential, derivative. Okay. So you learn this different maths, algebra 1, algebra 2, algebra geometry. Okay, let's look at this one. Okay, let me erase it. So basically, you learn one thing first. You learn y equal f of x, right? So y equal f of x, you can draw something on the coordinate. This is x, this is y. Okay, Liana, let me ask you, between x and y, which one is dependent variable, which one is independent variable? Which is dependent variable, which one is independent variable?
X is independent and Y is dependent.
Yes, because x is running by itself, so you get a value t.
Yeah.
You get some value of f of t. That would be your y value, yt value. Okay. So basically, f is free running, y depending on x. So you can draw a diagram. Maybe I don't know what it is. Okay, so if this equation is linear, then it's pretty much called algebra 1. If it is actually quadratic, then this pretty much is algebra 2. Okay, and then you may have trigonometry function. Trigonometry, that's not polynomial function. That actually you may have sinusoidal function. Then that's trigonometry. Okay, and then you study the different line, angle on the space. Then those kind of things is called geometry. Okay, so these are actually some part of the function. Everything is some part of function. So in pre-calculus, you actually learn something more. You also learn e to the power x. You also learn the logarithm function, log. In addition to the polynomial you learn, trigonometry function you learn, line that you learn, you also learn these different functions. So your function, in terms of function by the basic function, you will learn more, and you may also learn the absolute function. Okay, this different function, any kind of the function is part of the pre-calculus. So pre-calculus, you can also start look at it as the theory of functions. It pretty much talk about all kind of functions. Okay, so that's called pre-calculus. Okay. So you prepare algebra 1, algebra 2, algebra 3. Algebra 3, algebra 4 is your pre-calculus is called algebra 3 or algebra 4. Okay, so this whole thing, eventually, before you go to college, you will have the pre-calculus to include everyone. Okay, so that actually is including algebra 1, algebra 2, algebra 3, algebra 3, algebra 4, we sometimes call it pre-calculus. Okay, so now we call it pre-calculus. And then these are talking about y equals f of x. And there's a certain kind of f of x, quadratic, that actually is algebra 2. If you talk about a exponential function or log function, then it's algebra 3, 4. If it's actually a linear function, then it's algebra 1. Okay, that's what I look at. And then you go to calculus. So you take derivative of that function, or you do integral of that function. Then this one is calculus A, B, B, C. Okay, calculus A, B, or B, C. That's what you will learn over there. So this one actually got a new function. Let's assume that y equals x squared. Then this dx is 2x. Okay, y equal 2x. So basically, you find a new function that is your derivative. And this relationship of the derivative versus or the original function, this kind of study about function transformation that actually take a derivative, this is called calculus. Okay, this is called calculus. So calculus by itself is a symbolic operation. It's a symbolic calculation. Okay, what is a symbolic? Symbolic means that you give me a f of x equals x squared. Then your df dx, you also write down as a y prime, should be 2x. Okay? So that's the relationship you get. So basically, this actually is a operator. You put a function in, you will create a new function. So it's basically a function being taken as an input. You create a new function. So here it is a operation on functions. So it's a function on functions. We call it calculus. Okay. Usually you have a function. You put the data as input. You create another data. Data input, data output. This one, F is a function. While if you put a function as input, you create a new function. Then this kind of a function, we call it calculus. So calculus is actually function on function. Is that okay? Hello? Is that okay?
Yeah.
Yeah.
Calculus is function on function. Function is function on data. Okay, calculus is function on function. But Python, in a way, support both the function on function and also function on data. Okay, calculus actually, Python support that. So function on data is called numerical Python. A function on function is called symbolic Python. Okay, that's called symbolic Python. So if you actually look at Stanford do have a major that called Stanford symbolic system. Okay, so Stanford have a bachelor program in symbolic systems that really is dealing with functions, dealing with AI, dealing with calculus, dealing with lambda calculus. If you learn the Python, you know there's something called lambda, dealing with lambda functions. That's actually what Stanford is doing. Okay, they do have a master program for this symbolic. It's also considered as one of the major related to computer science. Okay, a lot of people get a degree from this symbolic system major. Okay, this one is close to AI degree or data science degree. Okay, so this is a pretty important major. Now let's go back to our parts. So basically, we will study data science to explore the mathematical relationship and graph, okay, related to the data. Okay, let's get started now. We talk about a lot of theory, but let's get started with one example. So let's get the first function. So let's call function 1 dot py. Okay. So this one, function 1 dot py. Okay. So here you may do this. You may do import numpy as np. Import matplotlib plot as plt. Okay. Let me check. Okay, let me check. PyProt, okay. PyProt, not plot. It's called PyProt. So this is a module called PyProt. You import it as a PyProt, called as PLT. Okay. So these two are what you want to include. the mathematical package for Python. One is NumPy, one is Matplotlib. When you include Matplotlib, you need to include as Matplotlib.pyplot, okay, Python plotting, okay. These two things. One is for numerical Python. One is for the plotting devices. Okay, two things that you need. Okay. Okay, now you may have a variable that's called x. So x, you may want to have some data. Say, let's assume that you actually do have a data, and your data is ranging from, let's see, 0.1 up to 10.0, but every time you increase by 0.1. Okay, so totally you should have a 100 point, right? Is that okay?
Yeah.
Totally you will have a 100 points. So you want to create such a x. So what should you do? You actually can do this. You should do a t divided by 10.0 or t in range function of from 1 to 101. Your range function will go from 1 to 101. Then you should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 100. And 101 not included. Each one of them you divide by 10. So your 1 divided by 10, you actually get 0.1. 2 divided by 10, you actually get 0.2. And then 100 divided by 10, you get 10.0. So this data actually is really ranging from, you create a x that actually ranging from 0.1 up to 10.0 totally. And this totally 101 points. Okay. 100 points. I'm sorry, 100 points. Now with that is your x. Okay, now you want to have a y, so y equals. Okay, you can do for t in x. Every x in t in x, you can get a f of t. Now you can define this f function right here. You actually define f function. Okay, any x function, you actually have every x function. Let's assume that you actually return 2 times x. So this one really is a f of x equals 2x. Okay, that is a simple definition. You can change the definition of this f of x in different way. Okay, so with that done, you actually can do this. You can do plt that figure, plt that show, and then plt that plot. You plot your x and y in green color. That's it. It's called Matplotlib. Okay, I'm sorry. Wrong spelling. Okay, you got a simple chart. So let's actually copy this one. This function 1 is actually passed as function 2. Okay. Okay, function 1, we actually get it down, but then just look at function 2. Function 2, we don't want to import this different module individually. So because right here, when you import them individually, the namespace is not merged. So you need to use the module name that. Okay, so we will change different way to import it. So that's import different way. Let's do from pilot import star. This is equivalent to from numpy import star. Also from Matplotlib. Including just like these two being done together. Okay, other than that, we don't change anything, but we do not need this figure plot anymore. That actually can be deleted. Okay, so this way and the original way is actually the same. Okay, so let's just save it. Okay. Okay, this is function 2. Any question so far? Any question so far?
No.
So here we teach you how to create an independent variable and create a dependent variable. Okay, both with this kind of the comprehension list. Okay, now let's copy this function 2 to function 3. Here we talk about pre-calculus and all kind of function. So that actually is very important because most of your scientific study, say your biology, your chemistry, your physics, will be depending on the pre-calculus a lot. Okay, so you kind of need that. Now we do use this not pilot. Okay, so let's do this. I can also do from these two. Okay. And then let's don't do pilot. Let's actually look at this. Okay. No, I'm sorry. Let me move it back. Okay. So let's do import. Okay. NumPy as NP. Okay. This one just we import NumPy as NP, but we also do from pilot import start. Okay. Let's do this. Now, this X using this range function to generate is not really professional. So let's actually delete it. We can use a NumPy package that linear space starting from 0.1 to 10.0, totally 100 points. So the range function can be replaced by this. Is that okay? So
Yes.
linear space actually creating all of the x one by one, starting from 0.1, then 0.2, and then totally 100 points up to 10.0. Okay, so y depend on it, so y have nothing to say. And it's plotting the same, let's actually change it to red color to make sure you know that it's different plot. Okay, it worked. So this is how we use a linear space. Any question? So in addition to linear space, NumPy also have log space. Okay, there's a log space function as well. There's a linear space function, there's a log space function. There are several space functions that you can use to create a space. Okay. Is that okay? Is that okay?
Yeah.
Now let's try another one. Let's try function 4. Okay. function for, let's do this. Let's actually do log space. So you get started from 0, 1, 2, 3, 4, 5, 2, 1, 2, 3, 4. So it actually 10 to the minus 5 to 10 to the power 4. And there's also 10 to the power 0. So totally 10 points is in log space. Okay. And you also got a y, whatever y you have. Okay. And then this one you can do log plot. There's a log plot, there's a log plot. There's a log plot, okay? There's a log plot. Log plot means that you have x in log scale, y also in log scale. That's actually log plot. Log plot is only x in log plot, y in linear plot. Okay, let's try this one. Okay, similar thing, but let's try this one. Log space, I misspelled it. One more time. Log plot, I'm sorry, I spelled the same thing wrong. Log plot not defined, let's see. Log plot using log space. And then what do you want to do? It's a semi-log y, okay. It's actually called semi-log y. There's a semi-log y plot. And then there is a semi-log x plot. Let's look at it. Okay, so this is not called log plot, it's called semi. So x is semi-log x. So it's a x domain is log. Okay. So let's try this one. Okay. X domain is log. Is semi-log x. Yeah. So this one is in log scale. This one is in the linear range, okay? And then overflow in the power. I'm sorry, I don't get it yet, okay? Before we do plugin, let me actually check, okay? Let's print out the X and Y. So actually it already create infinity. Let's don't do this, okay? Let's just do the X part. Okay, it has a lot of infinity. Let me check the log space function, okay? This one, numpy, log space. So what you need to do is from okay, you have to the start and end, and then the base. Okay. What else do we need to have? No, that's actually all we need to do. So the log space now that is you actually starting from -5 to 4, then base equals 10. Okay, that's the x should be. Okay, let's actually look at this one. Okay, so the linear space, log space that I use a little bit different. I think this one is -5 to 4. This one is okay. So that's actually also print the y. Okay, I think y also okay. Now let's actually turn on the semi-log part. Okay. Okay, so you two can see that right here, you have the log scale data on the x. You have its 2x value. Is that okay?
Yeah.
So that's what I want to tell you, to use NumPy to create your domain, your independent variable. Okay. And then give the function. You can use a linear space, log space, and different space. Okay, NumPy provide several functions for you. And then you use this kind of comprehensive function to create your Y chart. Okay. Okay, this one is up to here. Okay, up to here. That's what we want to learn. So that actually is talking about how to plot a function, and you can do from Pylab to import everything. You can do from these two to import everything. This both okay. This way or this way, either way okay. You can also including the. You can also just import the pyplot as PLT, NumPy as NP, okay, without merging the namespace. This is also okay. These are the way to import your NumPy and Matplotlib, okay? Okay, now, next one we would do simple Y plot. Now, next one, we're going to teach you how to decorate your chart. Okay, so a simple Y plot. Simple Y plot, you actually, from Pylab import start, you plot 1, 2, 3, 4, you plot out, show. Okay, that's it. Okay, that's actually plot function, okay? So we teach you the plot function, and we also teach you the so-called linear chart, scatter chart before. Okay, but it's okay. We just give you the different idea for the chart. Let's actually run it one more time. So after you do plotting, if you want to save this chart, you can do save the figure. Okay. And then you go to your directory, say Python list, data chapter 6. Right here, you can save as a JPEG file. Where is the JPEG? And there is no JPEG. Oh, here, JPEG. Join the photography expert group. So that's saved as a figure 1. And then that picture will be saved. Okay. Then the figure will be saved. Then you can later open the figure and copy it to your PowerPoint or something. Okay, this is the figure that you generate, your chart. Okay. Any questions so far?
No.
Okay, then we remove these print functions. Okay, up to here. Okay, up to here. Now next one, we will actually go back to the function. Okay, so this is a simple Y chart. Now next one, let's look at the sinusoidal function. So we will do sine function. Okay, let's create this one, sine and cosine. So let's call it sine.py. Okay, again, you can do from Pilot import star, okay? Then now you want to create a sine function, so you have a x is actually numpy that linear space. Okay, you want the numpy name, so you do import numpy as np, okay? And then you want to get it started from -2 times delta pi. Okay. Okay. Here you may want to import mesh. Okay. And then up to 2 times mesh the pi. Okay, so from -2 pi to 2 pi. So totally will be 4 pi. 4 pi, let's use 400 or 0.401 point. Okay. Because the beginning point and ending point, you need to add one more point. So that use totally 400 point. Each pi you have 100 point. Okay, that's the how this one I calculate. It's okay?
Yeah.
Okay, so AB pi I have 100 point. Now my y, okay, my y is a sine function, so I'm going to use a mass that sines of my t, okay, or t in x. Is okay. So this one basically getting a p variable, x variable. Okay, this x variable is from -2 pi to 2 pi, totally 100 points. So for each t, you will have sine t as your y. That's how we define it. Any questions so far?
No.
No.
No? No, we will plot it. So we will plot it. We will do plotting, then we will do figure. Show. And right here, you do plot your x versus y. Let's use blue color. Okay, that's a sine function. Let's actually add the cosine in. So let's actually have a g equal. If you have a second function, okay, you have second function, then you will do plot your x versus g in green color. Any questions so far?
No.
Okay, that actually is up to here. This parking your sine and cosine function. Anybody has trouble with sine and cosine?
No.
No? Next one, we are going to put the label into it and title to it. Okay, so you want to put a label. Label is the axis label, so you would put some sort of description right here, X label and Y label here, and the picture title. Okay, so we will put that. So let's do it. So this one we will do title. This one's called sinusoidal functions. Okay, and then X label. X. Okay. Okay. And then you do Y label. Okay. Okay. So your X label is right here, your title is right here, your Y label is right here. This is actually teach you how to decorate your chart. Any question? Any questions so far?
No.
No.
No? No, we are going to copy this sine pi to second one. This one is called sine 2, okay? So we are going to further decorating it, but I don't want to change the sine 1. So I copy to sine 2, okay? Okay, continue, this is sine plotting. So we do have the XY chart, but we want to have more of the decoration. So let's look at it. So this one, sometimes we may want to have the x-axis and y-axis. So you want to have a x-axis and y-axis. Okay, so you will say axis H line, horizontal line at the 0. Horizontal line is this line. Y-axis line at horizontal, and then the color is black. Line width is 1.0. Line width is how thick the line is. So let's try these two lines. So here you may draw a axis horizontal line at the 0.0 color in black color. Line width equals 1.0. And you may also draw another one. That's this one. Let me change it to red color. And let's put at axis V line, the vertical line. Then we will have two different lines. I showed in different color just to give you the idea of what they are. So this horizontal line is this line. Vertical line is this line, is red. Is okay? Is okay? Line width 1.0 is the same as this border's thickness of the line. So if you don't think that that's enough, let's try 1.5 to make it emphasized. Any questions so far?
No.
Okay, that's the line you see right here. Okay. How about Ian? Are you okay so far?
Yeah.
Next one, we will turn on the grid. Grid is these grid lines. So line width is smaller because the grid line usually not as thick as the exit line. Okay, you can use a blue color, and then we use dash. Okay, let's actually try this one. Okay, this one called grid. So you do grid, okay, and then line style equals column. And then line width equal 0.5. And then color equals blue. Okay. So these are teaching you how to prepare the chart. Okay. Okay. So you see the background has a dot, 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 dot. Okay. Background here you have dot, 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 dot. It actually using this dot, dot line. Here this is dot, dot line. If you don't like the dot, dot line, you can do this solid dash line. Then you will be dashed. You will be dashed line. Okay. There are several type of line, but here we just choose some. Okay, let's use the dot line again. So these are the grid. So we teach you the axis line and grid lines. Okay, these different lines. This one, okay. Okay, now let's actually do subplot. Okay, let's do subplot. So this one is drawing like this is fine, but sometimes you don't like to do it in this way. Sometimes you want to draw a separate sine line, separate cosine line. You actually don't want to put it in one plot. You want to do multiple plots. Okay, you want to put the multiple plots. So let's actually copy this one sine2 to another file called sine3.py. So XYZ the same, we don't change XYZ. Now the figure need to be changed. You don't use the so-called figure now, you will use a subplot. A subplot, you need to know about how to keep the subplot. So let's do subplot. Let's do Python subplot. So subplot, you have 2 row, 1 column. Okay, you have 2 row, 1 column. So you would have a 2 row, 1 column. 2 row, 1 column. Okay, so you would plot 2, 1. Okay. And then you will do pre-plot plus subplot. Okay. We will do this. Okay, we'll use this one. Okay. P-plot plus subplots. Okay. 2, 1. Okay, let's use this one. So this one actually is, you don't do this, okay? You do figure and axis. equal to subplots 2, 1. Okay, this one create 2 plots. Okay, so create 2 plots. One is figure, the main figure. One is called figure. One is called axis. Okay, one is called axis. So your first plot, your plot axis 0, the first axis you plot this. Your actually axis 1 will plot the z on it. Okay. So here you would have the figures title. Okay. And then your figures X label, figures Y label, and then figures width. Okay, and here you should have the axis 0's H line, and the axis 1's AB line. Okay, and this eventually you should show that's actually fine. Okay, this one you do figure show should be fine. Figure. These are fine. Okay, let's do it. So this is titles cannot be used. So let's just do title. No X label. Okay, so this one is do a X0's X label. A X0's Y label. A X0's grid. No attribute. Let's see. Find some subtract X labels. Oh, it's called set X label. I'm sorry. It's called set X label. Set Y label. Okay, one more time. Something wrong. This one, let me comment it down. This one is just too short. Okay, this one's done. So this is the chart. Okay, it's the X label, Y label. The AS1, we do not have it yet. So that's this one. Let's put it as 0 as well. Okay, this title I see is okay. Title is the whole chart. Should be okay. Let's run it one more time. Let's put this title on top. Okay, right here, as you can see, it's a little bit jammed in the middle, okay? It is a little bit jammed right here, okay? We can sub it, not doing this, let's actually use the figure size. So this one so far you subplot 0, 1, but you actually can set your subplot. Okay, let's do Python subplots. Okay. So you can use the figure size right here. Okay. Figure size is the width and height in inches. In inches. Okay, so let's try this one. So let's put right here the figure size. Okay. Let's do 10 inch, 10 inch. Okay. Let's do 10 inch, 10 inch. 10 inch will be actually a little bit top and to bottom will be longer. Okay, is better shown now. Okay. Any questions so far?
No.
So the lower part, you can also put your title in and the set label and this a grid, and this one you can copy everything and put it right here. And then actually change to 1 as well. If it works, you copy it second time, okay? Then you will create similar labeling over the second part. So this one is to teach you how to create a plot with 2 more channels. Is that okay? Any questions so far?
No.
If you want to plot the separate, you actually can plot subplot 1, 2, 3, 4. You can actually have 4 plots, okay? But right now we only use a 2 plot. You can have more plot if you like more plot, okay? Okay, that's actually is to plot a sinusoidal function and put those axis and label on it, okay? Now next one we are going to talk about the minimum and maximum. Okay, minimum and maximum. Now let's see. This one, let's call it sine 4. Okay, let's copy from sine 2 to sine 2 to sine 4. So this is x, y, z the same. We don't want to change. You plot this actually the same. Okay, the grid I think the same. Let's take out this the grid line. We don't like the grid line here. Let's delete it. The axis are good, but I don't like the red one as a axis now. Let me change it to black. Okay. Next one, what we would do is we will set the x minimum, y minimum. Let's assume that you don't like to look at minus 2 pi to 2 pi. You only want to look at pi to pi. Okay. You want to look at pi to pi. So you want to look at pi to pi. You don't want to look at 2 pi. Let's actually look at it. Okay. So you would use the X minimum, Y minimum, okay. So let's look at it, okay? Is you have the Python figure X minimum, X maximum, okay? So it's called S limit, okay? S limit, let's choose this one, okay? So here let's actually choose S limit from minus mass pi to mass pi, okay? Y limit is use minus 2 to 2, okay? So let's just save this one and run it. Okay, so as you can see, this y actually range from minus 2 to 2. And then now the x limited to from minus pi to pi. Your original data is 2 pi to 2 pi. But now we limit the boundary to pi and pi. Is that okay so far? Is that okay so far?
Yeah.
Okay. So these are plotting the one-dimensional chart. Okay, there are several other variables. We probably don't want to talk about it. Okay, it's okay now. Finding root, here it has a mathematical operation, so we don't look into it. Okay, this is finding root. Okay, so far so good. This one we finish up to here. Okay, next one we are going to talk about. So far we talk about the linear space and its related y function. Okay, so these are numerical solutions. Okay, these are numerical solutions. But sometimes you may have problem that is. You may have a function called f of x is like this. So can we move this one to the right by a? So what would be this function? If the black one is called f of x, y equal f of x. Then if we have a y1 equals red f of x, so what would be this red of f of x be? How to find that function? Anybody know? If we move to the right by a, what would be the new function for the red line? Anybody know?
-8.
Minus a. Why you think minus a will solve the problem?
Were you talking about like the new equation?
New equation, yes.
So you shift the 8 to the right.
Hmm?
You shift the original graph 8 to the right.
Yeah. So let's see. Sorry, I kind of lost it. So the question is that, yeah, minus A or plus A should be one of it, right? Should be one of it. You have a X, you have a Y. This line is called Y equal f of X. Then you actually move this one to the right. So this function to the right, y prime equals f of x. Okay. So in this one, f of x minus a or f of x plus a. Which one? And how to decide it? So let's assume here you have a point called xy. You move to the right on this line, they will have a point called big X and big Y. Okay, so original equation is y equals small x, small f of x equals big X y, right? You do have the relationship of the big X equals small x plus a, right? Big Y would be equal small y. Is that okay?
Yeah.
So your small x is equal to big X minus a. Small y should be equals big Y. Okay. So since your small x, small y fit into the black line, so your original function put x minus a equals big Y, this equation should hold because you put this one in the f of x, it should hold. So your equation would be y equals f of x minus a if you shift to the right by a. Is that okay? Hello, is that okay? So don't just say, oh, you will get bigger or smaller, plus or minus. You may get confused. Use this big Y, big X method, okay? Now let's actually try another one. So how about if your chart is like this? You have X, Y, your line is like this. This is Y equals f of X. Now this line actually moved down by a value of b. Then what should be this line? New function. Moved down by b. So now, since it moved down by b, so here you should have a point. Let's assume this point is xy. And move down by b here, you do have a point. Let's just say this point is still big X and big Y. So apparently your big X is the same, right? Your big X should be your small x. Your big Y should be your original Y minus b, right? Is that okay?
Yeah.
So your big X, your big small x should be your big X. Your small y should be your big Y plus b. So put this into the equation right here. Your big Y plus B need to be equal to f of big X. So your big Y should be equal to f of big X minus B. And that should be your red one's equation. So your red one's equation will be f of X minus B. Is that okay?
Yeah.
So this is the so-called big X, big Y method, okay? So far we are talking about this kind of transformation. We call it transition. Okay, transition, functional transition. So what are the transformation we have in graphics? What are the transformation you may have? Okay, right here, we do have a chart. No. Okay, anyway, these are different kind of a transformation that you may have, okay? So let's see, let me just take a picture. Let me change the title, okay? So that you may have scaling, you may have rotation, you may have translation, you may have tilting. Okay, these are different transformation you may have in your graph. So this kind of mathematical calculation would happen a lot in your image processing, in your graphics, in your robotics. It's everyday calculation, okay? Here we show you how to do the transformation, and you will use that in your function, okay? But mathematically, there are a lot of things that you can calculate, okay? There are a lot of things that you can calculate. Skewing, this one. So they are scaling, rotation, translation, and skewing. So this one, I think, is a very good chart. Okay, so far we just talk about translation. So translation means that originally your point is right here, you're moving to here. Your S, Y move to S plus A, Y plus A, Y plus B. That's how you move from here to here. This one, you do rotation from here to here, you do rotate. Scaling means they'll make it bigger or bigger here, or maybe smaller. Skewing means that your top portion move to the right, low portion not moving. It's called skewing. Is that okay so far?
Yeah.
These are typical mathematical calculation you need to be doing in what in graphics, in computer science, in website design, in all kind of anything related to transformation. Okay, all these we call it transformation. So you can go to here to look at this image analysis transformation, doing all kind of transformation. Okay, they do use a Python code, okay? They do use a Python code as an example. So these are different kind of, so you can read this article, okay? This article very good. Biomedical imaging. So, Belinda, what does this mean to you? Hi, Belinda, hear me?
Yeah.
What does this mean to you?
Like,
What does this mean to you? If you want to do biomedical study in college, or you summer camp go to some professor doing biomedical imaging operation, you will be doing this every day. Is that okay?
yeah.
That's what it said. Original one shifted to one. Original one rotated one. It may be an angle, but you want to make it a little bit, originally maybe a little bit this way, but now you want to rotate it a little bit back to this way. Is that okay?
Yeah.
For biomedical imaging, sometimes you will do scaling, make it bigger or smaller. Okay, the scaling and actually all kind of transform. Okay, make it bigger. Okay, something like that. So these are actually right here. I don't have the time to go into the detailed code, but these different detailed code are the Python code to adjust your image. Is that okay?
Yeah.
Okay. So here it do have the IO reader to read a file, okay, and then plot it, image show plot it, and then you actually draw it, okay. So they are example like that. Okay, you can look at this example. Okay, how they are transforming in mass. Okay, anyway, that's actually our purpose of study biomedical imaging. So let's go back. Okay. Let's go back. So right here, we're going back to here. Let's actually looking into the so-called this one is looking into something called science file, okay? Science file, so let's have the science file. So science file, let's keep the science function only. Okay, I don't want to do too many of them. So let's delete the white part, delete the so-called cosine part. Okay, let's delete the cosine part. Okay, so far so good. Let's actually just plug it. Okay, you have this. Now let's assume that you get this, you want to shift it to the right. You have the X, you have Y, you want to shift it to the right, okay? So let's study your original chart. Let's assume it's some sort of sine wave right here, okay? So you have the x for each t, you will do sine t right here. Let's assume that it shift to the right by a. Okay, so shift to the right by a. So shift to the right by a. So this point, original point is xy. New point is big X, big Y. Okay, shift to the right by a, your y is the same. So your big Y should still be your small y. Your big X should be your small x plus a. So your small x should be your big A minus a. Your small y should be your big Y, okay? And your f of small x will be equal to small y based on the original equation. This one would be your sine t, okay? Now you actually you will do your new equation. So this one is your sine x. So your new equation would be big Y would be equal to sine big X minus a. That would be your equation to move to the right. Okay, since that is the equation move to the right, so you will do z equals, okay, mass that sine t minus a, okay, for t in x. Now this is a should be, let's assume it's 0.5. Then your new product, okay, here this one should be your z, not x. Okay, sorry. Okay, so we do have the chart move to the right by 0.5. It's okay. So you need to know about pre-calculus before you can do transform on your graph. You don't know about pre-calculus, you are in big trouble. Okay, so must study the pre-calculus is harder. Any questions so far?
No.
No.
Okay. So this one is translation. Translation means that your big X, big Y will be your original small x plus a, big small y plus b. Even a bit different AB, your chart will be moving around. Okay. So if you have the scaling is different. Scaling your big X and big Y maybe equals 2 times X versus 1/3 of the Y. That's actually enlarge or shrinking. Is that okay?
Yeah.
Enlarge or shrinking. So by this one, actually, we have to look into it and then draw the chart based on your pre-calculus calculation. Okay, so that portion right here, I'm just covering up to here. Okay, making sure that you understand this one. We are trying to teach you how to make different plot for your mathematical function that you learn from pre-calculus. Okay. Using the lumpy and the Matplotlib, okay, and we also show you the subplots several subplots, okay, multiple channel subplots. And I don't want to make it too hard, but after class, you can also study this biomedical engine analysis for more advanced materials, okay? Okay, any questions so far?
No.
No, that's about it today. Today, our main purpose is introduce you how to decorate your chart, and also talking about more advanced functions. Next time, we are going to talk about tables and vectors and the metric. Because next chapter, we are going to talk about arrays, okay? Okay, that's it for today, okay? Good night and bye-bye.
Bye bye.